This is section 6.4. It's on isosceles triangles. This is what an isosceles triangle looks like. Two of the sides are congruent, and we're going to call those sides the legs. The one side that is not congruent to the two legs, we're going to call that the base. Now, there's two angles that touch this base, and we're going to call those base angles. There's one angle at the top that's in between the congruent sides. We're going to call that the vertex angle. This is theorem 6.2. It's the isosceles triangle theorem. It tells you if two sides of a triangle are congruent, angles opposite of those sides are congruent. So it's basically telling you if you know where the legs are, you should be able to identify the base angles. So for example, if these two sides are congruent, then this is the base, which means these are the base angles. So the theorem says across from a side with a mark is an angle with a mark. So if you have a triangle where those two sides are congruent, where would the congruent angles be? Well, those are the legs. This is the base. So these are the base angles. Likewise, here's your other option. And I messed that up. All right, so you already know this one. What if your legs live here? Then your base angles are here. That's what this isosceles triangle theorem tells you. If you know where the legs are, you should know where the base angles are. And then there's a converse of that theorem as well. If you know where the base angles are, you should be able to identify the legs. So for example, if these angles are congruent, then this is the base, which means the other two sides are the sides that are congruent. This is theorem 6.3. It tells you that the bisector of the vertex angle, so here's an isosceles triangle, that's the vertex angle. This would be a bisector of that vertex angle. The bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So if this segment bisects this angle, then these two angles are the same. It's also the perpendicular bisector of this base, meaning this comes down at a right angle. That's what the perpendicular means. And the bisecting of the base means that these two pieces are the same. So if you look at this for a second, notice how there's two triangles inside of an isosceles triangle. And these two triangles are congruent to each other. So since this is an isosceles triangle, these are the base angles. They're definitely congruent to each other. This segment is on both triangles. It's congruent to itself. These two triangles are congruent by side, 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 because you got three pairs of congruent sides. They're also congruent by side, angle, side. Or you could say they're congruent by angle, side, angle. Or angle, angle, side. Those methods show you that those two triangles are congruent. So every isosceles triangle that you have, there's this segment that comes down here and splits everything so that this triangle is a mirror image of that triangle. You have two congruent triangles inside of one isosceles triangle. So that makes it easy. If you know one thing about an isosceles triangle, you should be able to find lots of other things. So here's all the things you know about an isosceles triangle. Those sides are congruent. We have an isosceles triangle theorem that says, well, then these angles are congruent. We also have this other theorem that says, well, if you put this segment down here so that this angle gets bisected, you also know that this meets this side at a right angle. And this point is a midpoint. So those are the same. Clearly, this side is the same as itself. So if you know any one of these things on this isosceles triangle, you know something on the other side. Now, here's a couple corollaries, and this is really, really important. Let's say you have an equilateral triangle where you have three congruent sides. This is still considered an isosceles triangle, and it'll still behave like an isosceles triangle. But the point of the corollary is, if this is equilateral, then it's also equiangular. If all the sides are the same, then all the angles are the same. And if all the angles are the same in a triangle, remember what we know, they're all 60 degrees. Now, there's a converse to that. If a triangle is equiangular, then it's equilateral. If all the angles are the same, then all the sides are the same. Now, we can't determine how long the sides are. They could be a lot of different things. All the sides are the same, but they could be any length. We'll do this example next video.